Hello, this is paper 1 from the 2018 TMUA. So 75 minutes, 20 questions, might be in one video, might be in two, probably in one, we'll see how it goes. So question 1, find the value of this integral. Okay, so integral from 1 to 4, let's obviously split this into two terms, since we've got one term on the denominator, so 3x to the minus 3 over 2. Minus 2x to the minus a half dx. So that's going to be, what am I going to get? Minus 6x to the minus a half. And then minus 4x to the half. From 4 to 1. So I'm going to get minus 6 over 2, so minus 3. Minus 4 times 2, so minus 8. Then it'll be a minus 6 and a minus 4. So it's minus 11 plus 10 minus 1 d. Right, nice sort of standard opener. Question 2, arithmetic regression, first term a, common difference d. Sum of the first 5 terms is equal to sum of the first 8 terms. All right, relationship between a and d. So the first 5 terms, we're going to get 5 lots of a, and then 4 triangular of d, so that's going to be 10d, and that'll be 8 lots of a and then 7 triangular, so 28 lots of d. So I've got that 3a is minus 18d, a is minus 6d. C. Question 3, find the shortest distance between the two circles with these equations. So we've got one centre at minus 2, 3. We've got another centre at 7, minus 6. And so they're both changes of 9. So the distance between those is going to be the square root of 9 squared plus 9 squared. So that's going to be 9 root 2. But we have to take off, for the shortest distance between the circles, we need to take off the radiuses, don't we? So we're going to have to take off a root 18 and a root 2. So that's essentially saying we've got a circle and a circle. If I know the distance from there to there, I need to take off that bit and that bit in order to get the bit that's in between. So that's 3 root 2. So 5 root 2 all in all e. For simultaneous equations, that and that, find a complete set of values of a for which we have distinct real solutions for x. So we want to get something for x. So y is a minus x. Then sub into the top one, so 3x squared, and then we'll have plus 2ax minus 2x squared is 4. X squared plus 2ax minus 4 is 0. And we want two distinct real solutions. So 4a squared plus 16 greater than 0. Well, that's not hard to achieve. That'd be everything, wouldn't it? So all values of a, g. 5, function f defined by that. A, B, C take values 1, 2 or 3. No two of them being equal, not necessarily in that order. When divided by that, we get r. Divided by that, we get s. What's the largest possible value of r minus s? Okay, so if we're dividing by x plus 2, so we've got to put a minus 2 in and see what we get. So we're going to get a minus 8 plus 4a minus 2b plus c, and that is r. And then for s, we're putting a minus 3 in, so minus 3, so minus 27 plus 9a minus 3b plus c. That's s, and we want r minus s. So that's going to give 19 minus 5a plus b, r minus s. So we want to make that as large as possible. So we want a to be small and b to be large. So 19 minus 5 plus 3 is 17. D. 6. Find the number of solutions of this equation. Right, for 0 to 2 pi, so we've got sine 2x and a cos 2x, and then we're multiplying the sine 2x by x. But that's not going to make any difference, is it? Because changing amplitude doesn't change frequency. This feels like a physics question. Right, let's draw. So cos 2x, so we're doing something like, okay, it's going on for longer. The sine 2x, we're doing, I hate drawing these things. I always get it's so hard to get the intersection points in the same right place. So we're doing a like a forced oscillation type affair here for the sine 2x, but it's still going to be going through all of the same intersection points with the x-axis. So if we're thinking about cos, so cos has to get from here to here. So regardless of what we're multiplying sine by, we have to intersect. And then when it gets down to here, same thing. It needs to cut through in order to get down to 0. So we're still going to have the same number of intersection points as we would do. So, I mean, I've drawn this up to, well, this is half of it. And we're getting 1, 2 intersections. And then we're going to do it again because it's cos 2x and sine 2x. So we're going to have 4 intersections all in all, which is E. Yeah, it just doesn't really make that much difference. I mean, the sine is just going to be getting bigger and bigger, you know, as it goes on. But the frequency is the same, so it's still going to be intersecting 4 times. Question 7: a non-zero constant k is chosen so the coefficients of x to the 6 in the expansions of that and that are equal to each other. Okay, so x to the 6, so we're going to have 3 here, so we're going to have a k cubed. And then we're going to have a 7 factorial over 3 factorial, 4 factorial. And that's going to be equal to, so we'll have 6 there, we'll have 4 there. So we'll have k to the 4. And then we'll have a 10 factorial over 4 factorial, 6 factorial. So get rid of k cubed on either side, get rid of the 4 factorials on either side. So k is 7 factorial, 6 factorial over 3 factorial, 10 factorial. So let's say the 6 and the 3, let's marry those up. So 6 times 4 times 3, 6 times 5 times 4. And then the 7 and the 10 will leave 8 times 9 times 10. So make that one a half and that one a half. So I've got a quarter of 2/3. So that's a 6, which is A. That was quite a nice straightforward one. Question 8, sum to infinity of a geometric progression is 6, sum to infinity of the squares of each term is 12. What's the sum to infinity of the cubes? E. Okay, so 6 is a over 1 minus r. 12 is, well, first term would be a squared. 1 over a squared over 1 minus r squared. So I've got from here, a is 6 1 minus r. From here, I've got a squared is 12 1 minus r squared. Okay, so 6 squared 1 minus r squared is 12 1 minus r squared. So if I've got a 36 and a 12, I'll get rid of that and make this a 3. So I've got 3, 1 plus r squared minus 2r. 1 minus r squared, 3 plus 3r squared minus 6r. Then I'm going to, well, let's just written it out. I didn't really need to do that line, did I? 4r squared minus 6r plus 2 is 0. 2r squared minus 3r plus 1 is 0. So I'm going to be getting a 2r, well, they're both going to be minus 1s, and then r minus 1. We can't have r is 1 because it won't converge. So I've got r is a half, which means that a is going to be 3. And I want to get a cubed over 1 minus r cubed. So that is going to be 27 over 7 over 8. So 27 times 8 is 216 divided by 7. There we go, D. That's a fun question. 9. Complete set of values of the constant c for which this cubic, positive cubic, has 3 distinct real solutions. Right, so we've got this. We need 3 solutions. So we need the max to be greater than 0. We need the minimum to be less than 0. So 6x squared minus 6x minus 12. Oh, excellent, equals 0 to get these. So get rid of all these 6's. Equals 0. So I've got an x minus 2 and x plus 1 is equal to 0. That certainly works. So I've got x is 2. So that will be the minimum. And I've got x is minus 1, which will be the maximum. So for the maximum, putting a minus 1 in, I've got minus 2, minus 3, plus 24. Oh no, minus 1, I'm looking at 2s, plus 12, plus c must be greater than 0. So I've got that c must be greater than minus 7. Okay, so it's pointing towards B or D on the answers. Then for the minimum, so if I put a 2 in, so I'm going to have what, 16 minus 12 minus 24 plus c has got to be less than 0. So I need that. So what is this? Let's say the minimum, yeah, minimum less than 0. So I've got 36, c is less than 20 and greater than minus 7. So yeah, B. Okay. 10. Y and x, or even x and y, satisfy those inequalities. What's the greatest possible value of mod xy? Okay, so for x then, so x is going to have to be between what? If x was minus 4, it can't go to minus 5, so it'd have to be greater than or equal to minus 4. And if it was as high as, it can go up to 8, can't it? Because if it went beyond 8, we go below minus 6. So that's our range on x. For y, we can't go above 2. We could go down to minus 6. So we want to have the greatest magnitude. So it'll be those two, minus 48 mod it E 48. Okay. Question 11. Oops, gone a bit far. The line y equals mx plus 5, where m is greater than 0, is normal to that curve at the point PQ. What's the value of P? Okay, so we've got a number of things. We know that, well, let's put in, they're both passing through this point. So Q equals mp plus 5, and Q equals 10 minus p squared. Then we've got the normal to this curve. So the tangent is going to have gradient of minus 2p. So m is going to be 1 over 2p. Okay. So, well, if I put this into, actually that drops out really nicely in here, because I'm just going to get a half plus 5. So Q is 5.5. And then that is equal to 10 minus p squared. So p squared is 4.5, 9 over 2. So root it. So I'm going to have 3 over root 2, or 3 root 2 over 2, plus or minus. But m's greater than 0, so p's greater than 0, so plus. 3 root 2 over 2, c. Okay. Question 12. The curve has equation that's our f of x. P is greater than 0 and then less than q, which is then less than r. We're given these integrals. What's the total area enclosed by the curve and the x-axis? Right, so they've split it up. We've got a negative quartic. Negative quartic. Actually, we're going to have bits below the axis. So it's going through 0. So we're having something that's looking like this. So that's the 0. This is, okay, we've got P, we've got Q, we've got R. So we're saying going up all the way up to R. Let's call it, right, so A, B, C. So if we do A minus B plus C, if we're looking at actual areas, that comes out as 0 in the whole thing. If we're doing 0 to Q, that's minus 2. So A minus B equals minus 2. Okay, so C is equal to 2 then. Then we've got from P to R. p to r is minus 3, which means that b must be 5, which means that a must be 3, which means the total must be 10, which is f. That was a nice question as well. Like that one. 13. The function f of x as derivative f dash of x. The diagram below shows the graph of y equals f dash of x, which point corresponds to a local minimum of f of x. Right, so if it's a minimum of f of x, then f dash of x would be 0, and the second derivative will be positive, so it must have a positive gradient when cutting the x-axis. So C. Well, that was a gimme of a question. Then we've got 14. The line y equals mx plus 4 passes through those points. What are the possible values of p? So we've got, what we got? So we got log base 2 of p equals 3m plus 4. And we've got 4 equals m log base 2 of p plus 4. Okay, the 4's cancel on the bottom one quite nicely. So we could have that m equals 0, or we could have that log base 2 of p equals 0. So that would be p is equal to 1. Or if m was 0, we've got log base 2 of p equals 4. So p's 2 to the 4, which is 16. Okay, question 14. Log questions always seem to be really quick. Find the sum of the real solutions of this equation. So this looks like quadratic in root 3, doesn't it? So we've got root 3 to the 2x. Then, well, root 3 to the x, I mean, rather than just root 3. Then we've got a minus, so root 3 to the 4 will give us a 9. And then a root 3 to the x, then a plus 20 is 0. Okay, so that's like saying a y squared minus 9y plus 20 is 0. So that's going to be y is 4 or 5, where y is root 3 to the x. So we've got root 3 to the x equals 4 or 5. So let's do a... Well, if I make that an x over 2, do a log base 3. So log base 3 of 3 to the x over 2 equals log base 3 of 4 or log base 3 of 5. Okay, so that's just going to disappear. We'll have an x over 2. So I need to add these up. So I've got to do 2 log base 3 of 4 plus 2 log base 3 of 5, which is 2 log base 3 of 20, which is E. 16. The curve C has got that equation, b is greater than or equal to 0. Find the value of b that minimises the distance between the origin and the stationary point of the curve C. E. Okay. So, well, the minimum point we can get by completing the square. So that is going to be at minus b over 2. And then we'd have 2 minus b squared over 4. So that's where the minimum is. We need to minimize that, the distance of that point from the origin. So Pythagoras it to get b squared over 4 plus 4 plus b to the 4 over 16. And then minus, so we'll have a 2 times 2 divided by 4. That's all going to disappear and give us a b squared. So that's the square of the distance. So I mean, there's not really much point in square rooting it though, is there? Because if we want to minimize the square of the distance, it's the same as minimizing the distance. So yeah, let's just differentiate this. So I'll have a b over 2. That will go away. I'll have a b cubed over 4, and I have a minus 2b. So I want to set that equal to 0. So if b was equal to 0, actually let's have a look at the second derivative, would be minus 3 over 2 plus 3/4 of b squared. So when b is 0, it's giving me a maximum. So I've got a negative, so I don't want b is 0, but at least I can divide through by 0 then. So I'll have b squared over 4 is equal to 3 over 2. So I'd have b squared equals 6. B is greater than 0, so I'd have root 6, which is f. Okay, that was tough, I would say, compared to other things. Right, there are two sets of data. The mean of the first set is 15, mean of the second set is 20. One of the pieces of data from the first set is exchanged with one of the pieces of data from the second set. As a result, the mean of the first set increases from 15 to 16, mean of the second set decreases from 20 to 17. Right, so there must be 3 times as many things in the first set as there are in the second set, because we're getting the same change. You know, one of them's going up by a delta x, the other one's going down by a delta x. So if we're getting a change of 1 in here and a change in 3 here, we must have 3 times as many things here. So say we've got S1 with N1 objects or numbers, S2 with N2 objects. So I'm saying that N1 equals 3N2. And I want to get the mean of all of it. So that will be, well, 15 times N1 gives a total of set 1, plus 20 times N2, and I divide that by N1 plus N2. So N1 is 3N2, so that's 45, 65 N2 over 4 N2. Cancel those and then get 16 1/4 A. Okay, what we got? 3 to go. Question 18. What is the smallest possible, the smallest positive value of A, for which the line x equals A is a line of symmetry of the graph y equals sine 2x minus 4 pi over 3? Okay, so we've taken some sine function, we've got sine 2x, we've translated it. We want a line of symmetry, so let's think about this. So we've got something which is doing this without worrying about intercepts at the moment. So a line of symmetry is a peak or trough. And so we're going to have a positive value of A. We want a vertical line with a line of symmetry, smallest positive value of A, right? So we're either, we've got a couple of options then, haven't we, on this? So say we've got this and this. So we could have it that it's there, in which case this is going to be A. Or we could have it that is translated to there, in which case this is going to be A. We got one or t'other. And we want to be, oh good lord, right, this is tricky, isn't it? So we want to get either a 1 or a minus 1 out of this. And where do these things occur? So these occur at, so we want to have a pi plus or minus pi over 2, but we're going up. Oh, but does it matter that it's sine? No, it doesn't really matter, does it? I'm trying to think what the best way of putting this all together is. I mean, if we had this thing, so we need some value here. This thing's got to end up being positive and return a value of 1 or minus 1. So we need a positive value of x, which is going to return, well, it doesn't have to be a pi by 2 or pi. I mean, say we had pi over 2 all in all for this was 2x. I'm just getting myself into a mess of what I'm trying to do here. So say we had that and we were getting this, it was just returning a peak. Then we could say that we'd have on all of this, what are we going to want to have? So we've got pi over 2 plus 4 pi over 3 is 2x. So put these over 6. So that would be 3, that would be 8. So we've got 11 pi over 8. And then we divide by 2. So 11 pi over 16. If we were going for a minus, but it would still work with a minus, wouldn't it? Because we'd still get a positive result. Yeah, okay, I can see where I'm going now. So say we were going for looking for a trough on this. So we want to get the overall result here to be a minus pi over 2. we can't go down to the next trough because that would be going along another pi. That would be minus 3 pi over 2. So when we add on the 4 pi over 3, we've still got a negative number, and we get a negative x because 1.5 is bigger than 1 1/3. So the most we could go down is a minus pi over 2. So we do minus pi over 2 plus 4 pi over 3. So we've now got an 8 minus a 3. So 5 pi over, so how did I get 8 here? That should be 6, shouldn't it? And that would be 12. So that would be, I've lost my train of thought now. Yeah, so that's 8 minus 3, so that's 5 pi over 6 is 2x, so 5 pi over 12 is the best we're going to manage. Yeah, okay, that makes sense. Yeah, because we have to return either a -1 or a 1, and yeah, we can't get down to minus 3 pi over 2 inside that bracket and still have a positive x. The lowest we can go is minus pi over 2 and still have a positive x. So that would be our smallest positive value of a. Yes, okay, that was a really sneaky one. Question 19. Triangle ABC drawn with AB is 10, BC is 7, angle at A is equal to theta. Theta is a certain specified angle. The two possible triangles that could be drawn, a larger triangle has 3 times the area of the smaller one. What's the value of cos theta? Right, this definitely needs a picture. So I've got an AB, which is 10. I've got a BC is 7. Angle A is equal to theta. Okay, so I've got some angle here, theta. BC is 7. All right, I can see what I get. Right, so we can either go to here, or we could go to, say, here. These are our possible values of C, so like C and C prime. These are 7s. And we've got a small triangle when it's at C and a large triangle when it's at C prime. Okay, right, that makes sense. So we've got cosine rule, it looks like, doesn't it? So we'd have 7 squared equals 10 squared plus, well, I'm going to have to do this twice, aren't I? So C squared, I don't like having C prime there when I'm squaring it, but okay, whatever. Minus 20c cos theta, so that's one thing, but then I'll have that again for c prime, so I'll put that in a bracket, squared minus 20c prime cos theta, so I've got those. And then we've got this idea that the larger triangle is 3 times the size of the smaller one. So what do I do with that? So if I'm going to be doing a half base times height, if I go off 10 for the base, so they have the same base, they've got different heights. How would I get those heights? I could do it off of trig, because that would be a C sine theta and a C prime sine theta. Maybe, yeah, that'd work, wouldn't it? So I'd have the area of with C is going to be 10 over 2 times C sine theta. And for the other one, it'll be 10 over 2 C prime sine theta. And this one is the right-hand one is 3 times the other one. So 3 times that equals that. So get rid of that, get rid of that, get rid of that, get rid of that. So I've got 3C is C prime. Okay, that's good. Then I can come back to this equation then. So let's do I can get rid of those C primes in the second equation. 7 squared is 10 squared plus 9C squared minus 60C cos theta. Okay, so I've got 2 of those. Looks like should I subtract? Let's subtract this one from that. So there'd go, I'll get a 0 equals 0 plus 8c squared minus 40c cos theta. So c can't be 0, so let's get rid of those. I can divide through by 8 to get rid of those. So I've got that c is 5 cos theta. C equals 5 cos theta. Right, so I've got to go back in again. So I've got 49, let's actually make those into numbers, is 100 plus 25 cos squared theta minus 100 cos squared theta. Okay, so what does that leave me? That leaves me with 75 cos squared theta equals 51. Cos squared theta equals 51 over 75, which is 17 over 25. So cos theta is root 17 over 5. D. Right, that was a lovely question. Really was. A lot of work, but it was a lovely question. Question 20, find the value of that. Right, they've done that. I've seen this in other papers. Not a TMUA, but I've seen this in probably an NJA or an ESAT or something. Yeah, I can tell you it's E, but I'll go through why. So we want to pair these up. So if we do a sine squared 0 plus a sine squared 90, we can say that is sine squared 0 plus 1 minus cos squared of 90, which is equal to sine squared of 0 plus 1 minus sine squared of 0, which is 1. And we can do this with every pair. So you could do it again with a 1 and an 89, which would give a 1 and an 89, which would then give a 1 and a 1, as in the sine squared 1 will cancel with the sine squared 1. And we're left with 1. Every single time we pair these things up, we end up with the same thing. So we get 45 pairs, so that's 45 ones, and then it leaves us with the odd one out in the middle because we've got 91 terms in this sequence because we're going from 0 to 90. So the one in the middle is sine squared 45, which is 1 over root 2 squared, which is a half. So we've got 45 ones plus a half, which is 45 and a half. So yeah, it's the sneakiest question. It certainly helps who've seen it before, which, as I say, I have. They repeat some of these questions, and yeah, it's a bit of a bonus. I assume they would have done this on the same year, though. There would have been another 2018 paper that would have had the same question, rather than nicking it from another year. So some people would have seen it before. Anyway, that is paper 1 of 2018 TMUA. Paper 2 coming up.